Bismillahirrahmanirrahim. My dear student, I am Dr. Muhammad Yasin. Today we are going to learn the process of extraction of the alkaloids from the plant material. We will learn how the alkaloid materials are isolated from the plant material, and we will also learn the modern method for the purification of the extracted alkaloidal material. So let's move towards our topic about the extraction and purification of alkaloids. My dear student, I am Dr. Muhammad Yasin. Today it is our first lecture on the extraction and purification of alkaloids. In this lecture we will mainly discuss the different extraction methodologies that people are using for the extraction or the isolation of alkaloids from the plant material. This course belongs to the natural product course code 4119. Let's move towards our topic of extraction and purification of alkaloids. Remember, it is the first lecture on the extraction and purification of alkaloids. Here is a list of the key concepts that we are learning today. First of all, we will learn what is a solvent extraction. We will go into the brief discussion of the solvent extraction. Then we will discuss one by one the different extraction methodologies that people are using, like maceration, percolation, reflux extraction, microwave assisted extraction, pulse electric field extraction, and sonication, that people are using for the extraction or the isolation of natural products or the alkaloids from the plant material. We will go into the details of each of these extraction methods, and we will discuss the advantages and the disadvantages of each of the extraction method. We will also learn what kind of the apparatuses are used for the different types of the extractions. So let's move towards the solvent extraction first. The first thing that we are going to learn in the extraction or purification of alkaloid is the solvent extraction. Solvent extraction is basically a separation technique in which the two solvents that are immiscible with each other, the first solvent is mostly the aqueous and the second solvent is mostly the organic, come into contact with each other. One of these solvents contain the solute. This solute is distributed then in between the two immiscible phases. The distribution of the solute between the two phases, the one is the aqueous and the other is the organic, is governed by the distribution law or the partition process. This technique is called the solvent extraction or the liquid extraction. So in this separation technique, the solute goes from one phase into another phase, and the distribution of the solubility of the solute between the two phases is governed by the partitioning process. On this slide, I have shown you the apparatus that is used for the solvent extraction. It consists of a separating funnel. The separating funnel may be in a pear shape or it may be in the oval shape. So I have shown the separating funnel on this slide. When the solute, that is either liquid or solid, is added to the heterogeneous system consisting of two immiscible liquids, in both of these two liquids the solute is soluble. The solute then distributes between these two immiscible liquids according to the Nernst distribution law. I am not going into the detail of the solvent extraction method. I have just shown how the solvent extraction method works. Before going into the detail of the extraction of alkaloids from the plant material, my question is, where does medicines come from? Have you ever stopped to consider all of the drugs that are on the market today for the wide range of illness and ailments we suffer from, like sinus infection? There is a drug for that. You suffer from diabetes. Luckily, there is a medicine for that too. But where did those drugs come from? Although it is true that a lot of prescription drugs are made by synthetic organic chemists in the lab, what you may not realize is that a lot of the molecular architectures we use today in the clinical setting were either derived from or inspired by the molecules found in nature. It turns out Nature is extremely good at using biological machinery to construct the compounds that are not only structurally complex but also very useful to humans for medicinal applications. Today we are going to be talking about the specific class of the compounds found in nature known as the alkaloids. Our primary focus or the focal point will be on how they are isolated and purified from the natural sources. Let's start it. What is an alkaloid? Let's start by briefing talking about how alkaloids are defined. An alkaloid is simply a compound derived from natural sources like plants or bacteria that contain a basic nitrogen atom. A basic nitrogen atom means that the nitrogen itself contains a lone pair of electrons that can be used to react with an acid or some salt. You may already be familiar with the very popular alkaloid without knowing it. The compound known as the morphine is a very important alkaloid that was isolated from the poppy seed of opium poppy plants back in 1804, and is heralded for its pain-relieving properties. It is also received a lot of negative press due to its highly addictive nature. Notice that lone pair of electrons on the nitrogen atom, although which is what makes it an alkaloid. So alkaloids are heterogeneous compounds in which the nitrogen is present. So literal meaning of alkaloid is also like alkali. So all the alkaloids are alkali-like substances which contain the nitrogen in their heterogeneous ring. So this definition is true for the majority of the alkaloids, although there are some exceptions that we have discussed in the previous lecture. If we talk about the background or the history of the use of the alkaloids and their extraction process, it dates back to the thousands of years back. Natural medicine such as traditional Chinese medicine and Ayurveda were formed and developed in the daily life of the ancient people, and in the process of their fight against diseases over thousands of years, and they have produced a positive impact on the progress of human civilization. Today, natural medicine not only provides the primary healthcare needs for the majority of the population in developing countries, but have attracted more and more attention in the developed countries due to the soaring healthcare cost and universal financial austerity. In the United States of America, approximately 49% of the population has tried natural medicine for the prevention and treatment of diseases. Chemicals known to have medicinal benefits are considered to be active ingredients or active principles of natural medicine. Natural products have provided the primary source for new drug development. From the 1940s to the end of the 2014, nearly half of the Federal Drug Authority approved chemical drugs for the treatment of human diseases were derived from or inspired by natural products. Natural products offer more drug-like features to molecules in the terms of functional group, chirality, and structure complexity. The amount of the active ingredients in natural medicines are always fairly low. The lab-intensive and time-consuming extraction and isolation process has been the bottleneck of the application of natural products in drug development. There is an urgent need to develop the effective and selective methods for the extraction and isolation of bioactive natural products. So that is why people have developed efficient extraction methods for the extraction or the isolation of biologically active compounds from the plant material. Here in this lecture we will study the general methods for the extraction and isolation of alkaloids from the plant material. Extraction is the first step to separate the desired natural product or the alkaloids from the raw material. Extraction methods include solvent extraction, distillation method, pressing, and sublimation according to the extraction principle. Solvent extraction is the most widely used method. The extraction of the natural product from the alkaloids progresses through the four stages. In the first stage, the solvent penetrates into the solid matrix, that is the plant material, and in the second stage, the solute dissolves in the solvents, and in the third stage, the alkaloids are diffused out of the solid matrix, that is the plant material, and in the fourth stage, the extracted solute or the alkaloids are collected. Any factor enhancing the diffusion and the solubility in the four steps or in the four stages will facilitate the extraction. The properties of the extracting solvent, the particle size of the raw material, the solvent to solid contact surface area, the extraction temperature, and the extraction duration will affect the extraction efficiency. The selection of the solvent is crucial for solvent extraction. Selectivity, solubility, cost, and safety should be considered in the selection of the solvent. Based on the law of similarity and intermiscibility, like dissolve like solvent with a polarity value near to the polarity of the solute or the alkaloids are likely to perform better and vice versa. Alcohols like methanol and ethanol are universal solvents in solvent extraction for phytochemical investigation. Generally, the finer the particle size is, the better results the extraction achieves. The extraction efficiency will be enhanced by the small particle size due to the enhanced penetration of the solvent and the diffusion of the alkaloids. Too fine particle size, however, will cause the excessive absorption of the solute in the solid and difficulty in subsequent filtration. High temperature increases the solubility and the diffusion. Temperature that too high, however, may cause the solvent to be lost, leading to the extracts of undesirable impurities and decomposition of thermolabile components. The extraction efficiency increases with the increase in the extraction duration in certain time range. Increasing time will not affect the extraction after the equilibrium of the solute is reached inside and outside the solid material. Here on this slide, I have listed the factors that chiefly affect the solvent extraction. These factors have been discussed in the previous slide. However, on this slide, I have just listed these factors. The main factors are the properties of the solvent that is used for the extraction, the particle size of the plant material, solvent to solid ratio, temperature, and the extraction duration. High temperature increases the solubility and the diffusion. Too high temperature, however, may cause the decomposition of the thermolabile components. The extraction efficiency increases with the increase in the extraction duration of the time in a certain time range. Increasing the time beyond this certain time range will not affect the extraction efficiency, since the equilibrium of the solute is reached inside and outside the solid material. So these are the main factors that affect the efficacy of the efficiency of the solvent extraction. Solvents with a polarity value near to the polarity of the solute are likely to perform better and vice versa. The greater the solvent to solid ratio is, the higher the extraction yield is. However, a solvent to solid ratio that is too high will cause excessive extraction solvent and require a long time for concentration. The conventional extraction method, including maceration, percolation, and reflux extraction, usually use organic solvents and require a large volume of solvents and long extraction time. Some modern and greener extraction methods, such as supercritical fluid extraction or SFC, pressurized liquid extraction, which is usually abbreviated as PLE, and microwave assisted extraction, that is mostly abbreviated as MAE, have also been applied to natural product extraction, and they offer some advantages such as low organic solvent consumption, shorter extraction time, and higher selectivity. Some extraction methods such as sublimation, expeller pressing, and enfleurage are rarely used. So these are some of the methods, solvent extraction methods that have been used by the people for the extraction of alkaloids and other natural products. Maceration is a type of solvent extraction. It is an extractive technique that is conducted at room temperature. It consists of immersing a plant material in a liquid such as water, oil, alcohol, etc. This is a very simple extraction method with the disadvantage of long extraction time and low extraction efficiency. It could be used for the extraction of thermolabile components. However, it has the disadvantages of the low extraction, long extraction time and low extraction efficiency. This method has been used mostly for the extraction of phenolic compounds from the chokeberry fruit. Percolation is a method used for the extraction of alkaloids from the plant's material. Percolation consists of two words, per means through and polar means to stir. So the literal meaning of the percolation is pass a liquid through a solid plant material drop by drop. This is a process in which an alkaloid or the alkaloids are extracted by the slow passage of a suitable solvent through a column of plant's material at room temperature. Percolation is more efficient than maceration because it is a continuous process in which the saturated solvent is constantly being replaced by a fresh solvent. In the case of maceration, it is not a continuous process as the plant's material remains dipped in the same solvent. So the percolation has the advantages that it is a continuous process. The process of percolation includes 5 steps. The first one is the comminution of plant material. The second step is the imbibition of plant material. Third is the packing, and the fourth is maceration, and the fourth is the percolation. So the percolation process consists of 5 steps that are shown or listed on this slide. On this slide you may see a photograph of the percolation process. You may see that the plant material is packed on a conical flask and it is constantly flowed with the fresh solvent, and the solvent after percolation gets deposited into the funnel. As I have earlier informed you that the percolation process consists of 5 stages. The first stage is the comminution of plant material. What is comminution? Comminution is the size reduction of the plant material, usually from coarse powder to fine powder form, so that to increase the surface area, it will increase the surface area of the plant material, and to ensure the complete removal of alkaloids from the plant material. When the surface area of the plant material will be increased, the contact between the solvent, flowing solvent, and the plant material will be enhanced, and hence the diffusion of the alkaloids from plant material into the solvent will also be increased. It will also slow down the movement of the solvent, and hence the fine powder plant material will produce more resistance to the flow of the solvent. It will also help in the uniform packing of the plant material. So comminution of the plant material is the reduction of the size of the plant material, and it will help in the diffusion of the alkaloids into the solvent. Imbibition of plant material is the second stage of percolation process. Swelling of the plant material by absorbing Nernst may be achieved by standing the solvent in the plant material in a closed container for 4 hours. It helps us to avoid the choking or the difficulty of the movement of the solvents. It also helps to remove the air from the plant material, and it also helps us to avoid the washing out of the fine particles of the plant material. Packing of the plant material is the third stage of percolation process. After imbibition, plant material is evenly packed into a percolator. A filter paper is placed on the bottom to support the column of the plant material. Then the moistened plant material is placed on the filter paper. Over the moistened plant material and other filter paper is placed having a weight on it, then menstruum is added. Close the lid if the menstruum or the flowing liquid is volatile. It will provide the even packing or the fine packing of the plant material for the percolation process. On this slide, I have shown the packing of the plant material. If you talk about the packing of the plant material, then at the top you may see a lid. You may place a lid if your menstruum or the flowing liquid is volatile. Then comes the your liquid. At the bottom you may see a stopper on which a filter paper is placed. Over the filter paper I have placed the moisture. I have shown the moisture plant material that contain the alkaloid material. Over the plant material I have placed another filter paper over which I have placed a small weight, so that the filter paper is not displaced. So this is the graphical representation of packing of the plant material used for the percolation process. Extraction is the first step to separate the desired natural product or the alkaloids from the raw material. Extraction methods include solvent extraction, distillation method, pressing and sublimation. According to the last stage is the percolation of plant material. It consists of following steps. After 24 hours, lower orifice is opened and menstruum is collected with a controlled speed until 3/4 of the menstruum is collected, followed by the addition of more menstruum. All the menstruum is collected from the lower orifice so that the milk does not become dry. Milk is then pressed to get extract which is combined with the previous liquid. Finally, it is allowed to stand and then it is filtered. Nowadays, modified percolation methods are used, which include reserve percolation method, continuous hot percolation method and cold percolation method. In the reserve percolation method, the first portion, that is about 3/4 portion of the percolate, which contains maximum amount of the active constituents, which made about 70 to 80% of the alkaloid, is reserved as such. The last portion of the percolate, that is about 1/4 portion, is collected separately and the menstruum is evaporated to get syrupy consistency. It is then mixed with the reserve percolate. Final volume is adjusted by adding more menstruum. Usually alcohol is used as menstruum for reserve percolation, for example liquorized liquid extract. So nowadays people are using, instead of simple percolation method, either the reserve percolation method, continuous and hard percolation method. On this slide I have shown the details of the reserve percolation method, in which the first portion of the percolate is separated again, is collected separately, whereas the last portion, which is about 1/4 of the total menstruum, is collected separately. Both these collections are evaporated separately and then the obtained syrupy contents are mixed together, and then again the alcohol is added and the final volumes are adjusted. So this is the reserve percolation method. Solvents with a polarity value near to the polarity of the solute are likely to perform better and vice versa. The greater the solvent to solute ratio is, the higher the extraction yield is. However, a solvent to solute ratio that is too high will cause excessive extraction solvent and require a long time for concentration. The conventional extraction method, including maceration, percolation and reflux extraction, usually use organic solvents and require a large volume of solvents and long extraction time. Some modern and greener extraction methods, such as supercritical fluid extraction or SFC, pressurized liquid extraction, which is on this slide. Comminution extractor is shown. Comminution extractor have a side condenser which is used to condense the vapors of the menstruum, which are used again and again for continuous hot percolation. Mostly continuous cold percolation method is used. The purpose used for continuous cold percolation method is called the solute extractor. The solute extractor is shown on this slide. Reflux extraction is basically a solid liquid extraction process at a constant temperature with repeatable solvent evaporation and condensation for a particular period of time without the loss of solvent. This system is widely used in herbal industries as it is efficient, easy to operate and cost effective. It is more efficient than percolation and maceration and requires less extraction time and solvent. However, it has the disadvantages that it cannot be used for the extraction of thermolabile natural products. Depucation is a method of extraction by boiling the herbal or plant material to dissolve the chemicals of the material, which may include stems, roots, barks, and rhizomes. Depucation involves first mashing the plant material to allow for maximum dissolution and then boiling in water to extract oils, volatile organic compounds, and other various chemical substances. Depucation can be used to make tisanes, tinctures, and similar solutions. Depucation and infusions may produce liquids with different chemical properties as the temperature and or preparation difference may result in the oil-soluble chemicals in the depucation versus infusion. Depucation process can also be applied to meats and vegetables to prepare the bouillon or stocks. Although depucation term is typically only used to describe boiled plant extracts, usually for medicinal or scientific purposes. Depucation is also the name for the resulting liquid. Although this method of extraction differs from infusion and percolation, the resultant liquids can sometimes be similar in their effects or general appearance and taste. The extract from depucation contains a large amount of water-soluble impurities. Depucation cannot be used for the extraction of thermolabile and volatile components. Pressurized liquid extraction has also been described or known as the accelerated solvent extraction, enhanced solvent extraction, pressurized fluid extraction, accelerated fluid extraction, and high pressure solvent extraction by different research groups. PLE or pressurized liquid extraction applies high pressure in extraction. High pressure keeps solvents in a liquid state above their boiling point, resulting in a high solubility and high diffusion rate of liquid solutes in the solvent and a high penetration of the solvent in the matrix. Pressurized liquid extraction dramatically decreases the consumption of the extraction time and solvent and have better repeatability compared to other extraction methods. Supercritical fluid extraction or SFE uses supercritical fluid or abbreviated as SF as the extraction solvent. A supercritical fluid is any substance at a temperature and pressure above its critical point where distinct liquid and gas phases do not exist. It can effuse through solids like a gas and dissolve materials like a liquid. In addition, close to the critical point, small changes in pressure or temperature result in large change in density, allowing many properties of a supercritical fluid to be fine-tuned. The fluid will also be called supercritical even if its temperature is below critical point value. In that case, it will be a highly compressed liquid, but pressure is mandatory to be above its critical value. Superfluid has similar solubility to liquid and similar diffusion power as that of gases and can dissolve a wide variety of natural products. Their solvating properties dramatically change near their critical points due to a small pressure and temperature changes. Supercritical carbon dioxide, abbreviated as SCO2, is widely used as supercritical fluid extraction in superfluid extraction because of its attractive merits such as low critical temperature, that is 31 degrees centigrade, high selectivity, inertness, low cost, non-toxicity, and capability to extract thermally liable compounds. The low polarity of supercritical carbon dioxide makes it ideal for the extraction of non-polar natural products such as lipids and volatile oil. A modifier may be added to supercritical carbon dioxide to enhance its solvating properties significantly. The last stage is the percolation of plant material. It consists of following steps. After 24 hours, lower orifice is opened and menstruum is collected with a controlled speed until 3/4 of the menstruum is collected, followed by the addition of more menstruum. All the menstruum is collected from the lower orifice so that the milk does not become dry. Milk is then pressed to get extract which is combined with the previous liquid. Finally, it is allowed to stand and then it is filtered. Microwave assisted extraction is another method that people are using for the extraction of alkaloids and other natural products. Microwave generates heat by interacting with polar compounds such as water and some organic components in the plant matrix following the ionic conduction and dipole rotation mechanism. The transfers of heat and mass are in the same direction in microwave assisted extraction, which generates a synergistic effect to accelerate the extraction and improve the extraction yield. The application of microwave assisted extraction provides many advantages such as increasing the extract yield, decreasing the thermal degradation, and selective heating of the vegetal material. Microwave assisted extraction is also regarded as a green technology because it reduces the use of organic solvent. There are two types of microwave assisted extraction methods: a solvent-free extraction usually for volatile compounds, and solvent extraction usually used for the non-volatile compounds. First, electric field extraction involves the application of high voltage pulses for a few microseconds to plant material placed or flowing between two electrodes. First, electric field extraction significantly increases the extraction yield and decreases the extraction time because it can increase mass transfer drug extraction by destroying membrane structure. The effectiveness of pulse-electric field extraction treatment depends on several parameters including field strength, specific energy input, pulse number, and treatment temperature. Pulse-electric field extraction is a non-thermal method and minimizes the degradation of thermolabile alkaloids. Packing of the plant material is the third stage of percolation process. After imbibition, plant material is evenly packed into a percolator. A filter paper is placed on the bottom to support the column of the plant material. Then the moistened plant material is placed on the filter paper. Over the moistened plant material, the process of percolation includes 5 steps. The first one is the comminution of plant material.